This will be a 5-part series on graphing linear inequalities. I need to mention first that the method I'm going to use is the method of crossing out or shading the false side. Most textbook authors require you to shade the true side, so that's why I think it's important that you note that here we're going to be shading the false side. So if you're not a student in my class, you're just going to shade the opposite side of the line as I am. So I have some basic directions outlined here, but the first thing that you want to do when you graph a linear inequality is make sure is it solved for y. And it is. More specifically, we want it in slope-intercept form, which it is. And I want to note the y-intercept is the point 0,4, and the slope is -1/1. Oh, you can't see that. Slope is -1/1, which means we will be moving down and to the right. So I'm going to graph the line represented by the inequality y is less than or equal to -x plus 4 by first plotting the y-intercept. The first point you always graph on a line with slope is going to be on the vertical or y-axis. The point 0,4 means from the origin I do not move left or right, only up 4. And then with the slope of -1, that tells me from this point I need to come down 1 and right 1. The slope is rise over run, but since it's negative, we need to fall. So our rise is in the negative direction. And I have a habit of continuing my dots all the way to the edge of the graph when I'm doing this by hand, because I want to make sure when I line up my straight edge that it's very accurate. So now that I have several points on my line and I'm reaching for my ruler, I need to decide, based on this inequality here, if I should use a solid or dashed. Since there is a partial equal sign in the inequality, I'm going to use a solid line. Now, if this was just an equal sign, then my solid line would be just fine. But because it's an inequality, I need to pick a test point. And my favorite test point to use is the point 0,0. And I refer back to the original inequality. So when y is less than or equal to -x plus 4, I need to replace both the x and y coordinates with 0 and determine if the resulting statement is true or false. So replacing y and x and simplifying gives me 0 is less than or equal to 4, which is a true statement. 0,0 is right here. Let's call it beneath the line, and that gave me a true statement. So if points beneath the line are true, then points above the line have to be false. And I want to cross out or shade the false side of the line. Okay, moving on to the next example. I've got the inequality y is greater than 5x minus 2. So, is it solved for y? Yes. Is it in slope-intercept form? Yes. So we are ready to progress. So I'm going to identify the y-intercept is the point 0, -2. So from the origin I go down 2 units and put my dot. And the slope is 5, but I need that to be a fraction that represents rise over run, or vertical change over horizontal change. So you can make any whole number into a fraction by putting it over 1. Since this is positive, that's indicative of moving up and to the right. So from my y-intercept, I need to move up 1, 2, 3, 4, 5 units and right 1. And I'm going to do that again. So that when I make my line, I'm nice and accurate. Now, if you're using a calculator or some kind of computer software, you define 2 points on the line, it'll make it very accurate for you. But with human error, if I didn't have that third point, I could kind of draw it like this, or I could draw it like this, and you could see I'm missing a point. So several points are very helpful in getting an accurate line. Now because my inequality is a strict inequality, it's y is greater than, and there's no equal sign in it, that means I'm going to have to use a dashed line because the points on the line cannot be part of the solution set. So I think you can tell that 0, 0 is to the left of that line. I'll put my straight edge up again, and you could tell that 0, 0 is to the left of the line. So I can use that as a test point. So in the original inequality, I replace both the y and the x with 0, and I get 0 is bigger than -2, which is true. That means points on the left of the line are true, therefore points on the right have to be false. And remember, I'm crossing out or shading the false side because that's what the author of my textbook tells me I have to do. Okay? Moving on to example 3. Oh, this one is not solved for y, nor is it in slope-intercept form, so I should probably work on that first. I've got x minus y is less than -1. So I'm going to start by subtracting x from both sides, and I get -y is less than -x minus 1. Put the x first because I'm looking for slope-intercept form. Here I still have -y, and I don't want -y, I want +y. So in order to get rid of that negative sign, I'm going to divide all of the pieces by -1. When I multiply or divide an inequality by a negative, I have to make sure that I change the direction of the inequality. So the y is less than turns into y is greater than when I divide by a negative. Y is greater than x plus 1. Okay, and so the y-intercept is the point 0, 1, and the slope is 1. Remember, we can make that into a fraction by throwing it over 1. Because it's positive, that indicates that we're moving up and to the right. So my first point is the y-intercept of 0, 1. And from there, I'm going to move up 1, right 1. Repeatedly until I get to the edge of the graph, so that when I line up my straight edge, I get a nice accurate line. Now, similar to the previous example, we have a strict inequality, which necessitates a dashed line. So I need to be careful, especially because I'm using pen to do math. Isn't that silly? I need to be careful that I remember to make my line dashed, because points on the line are not part of the solution. So finally, I choose a test point. You know which one I like. It's 0, 0. And in the original inequality, I replace both x and y with 0, and I get that 0 is smaller than -1. Nope, that's false. So points below the line result in a false statement when they're evaluated. So I cross out or shade the false side. I'm going to stop here and continue on with examples 4 and 5 in another video.